This is First Coast Math Clinic with Lesson 5, Solving Application Problems with Integers from Unit 1, Number Operations with an Algebra and Pre-Algebra focus. So the goal in this video is to represent and solve application problems with integers. So just a quick review of integers. We know integers are positive and negative whole numbers. I have another video that talks about integers and types of numbers. So our integers, right, we're going to start with 0 in the middle, positive values to the right. So we've got 1, 2, 3, 4, 5, and 6, and so on. And then the negative equivalent values to the left, negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. So our positive and negative whole numbers, values not including decimals and fractions. So let's get into some examples where we look at application problems, we represent them using integers, and then we solve them. All right, so for number 1, you begin on a hill 45 feet above sea level. You then scuba dive to a depth of 54 feet below sea level. What is the change in height? So we kind of represent this, right? So if sea level is like right here, right? And we're starting kind of above sea level. So that's like our above sea level is going to be right here. So we're on a hill, and this is our like height of 45 feet. So we start there. And then we go to a depth of 54 feet below sea level. So we're here, and we're going to go down. So this is sea level, so that's going to be like 0, right? So we're going down. And if this is below sea level, that's going to be a negative value. So that's going to be negative 54 feet. So we can represent that as negative 54 feet. So how are we going to find this? We want the change in height. So to find our change, we're going to subtract. So we could do our highest point minus our lowest point. So we've got 45 minus negative 54. So we're doing negative 54. And actually, let me put this, represent this a little bit differently. So that negative 54 is going to be right here because we're 54 feet below sea level. So it's a depth of 54 feet. Right, so let's use our subtraction rule. We want to keep change flips. So we're going to keep the 45, change subtraction to addition, take the opposite of that second term. So we've got 45 plus 54, and we get a distance of 99 feet. For number 2, the current temperature is 12 degrees. So let's just get some information. So the current temperature is 12 degrees. It's predicted to drop 15 degrees in the next 2 hours, then 3 more degrees the following hour. What will the temperature be in 3 hours? So 3 more degrees in the following hour. So it's going to drop 15 degrees. So it starts at 12 degrees. So it's a positive 12 degrees. It's going to drop 15 degrees. So this is going to be a minus 15 in 2 hours. Then it's going to drop 3 more degrees. So that's going to be another minus 3. All right, so if we represent this, it's going to be 12 minus 15 minus 3. So this is going to be like that 15 is 2 hours, and the 3 is going to be 1 more hour. So it's like 2 hours, 1 hour, and that's your 3 hours right there. So let's go ahead and solve this. So starting with 12 minus 15. So we do 12 minus 15. We're subtracting a smaller number minus a larger number. So our answer is going to be negative. And then 12 minus 15, the difference between 12 and 15 is going to be 3. So we're going to get negative 3. So it's going to be negative 3 degrees after 2 hours. Then it's going to drop 3 more degrees. So let's use our subtraction rule. Keep, change, flip. So negative 3, subtraction becomes addition, and then this positive 3 becomes negative 3. So we get negative 3 plus negative 3, and we get negative 6 degrees. All right, let's look at another example. So for number 3, it is -3 degrees and will rise 14 degrees by 10 a.m. What will the temperature be at 10 a.m.? So it's -3 degrees and it's going to rise. So we're going to add that because it's going to be a positive 14. So plus 14. So we're adding two numbers of opposite signs. When we add two numbers of opposite signs, we want the difference. Well, what's the difference between 14 and 3? The difference between 14 and 3 is 11. So 11 degrees. And what's the sign going to be? Should that be a negative degree or positive degree? When we want the sign of the number with the larger absolute value, the number that's further from 0. So what number is further from 0? Is it the -3 or is it the 14? Well, that 14 is further from 0, so our 11 is going to stay positive, okay? So think about it this way. Think about it this way on a number line. Negatives over here. We're at 1, 2, 3 degrees. Then it rises 14 degrees. So it's going to increase those 3 degrees and then 11 more to get to positive 11 degrees. Okay, let's do one more example. So for number 4, the highest point on Earth is Mount Everest at 29,029 feet above sea level. The lowest point on Earth, is the Dead Sea at 1,414 feet below sea level. What is the difference between the highest point and the lowest point? So, if we kind of illustrate this, all right, we've got our highest point here. So this is Mount Everest. Here, that's 29,029 feet. Sea level is going to be right here, and that's going to be 0. And then the lowest point right here is going to be the Dead Sea, and that's going to be negative 1,414 feet because it's below sea level, it's below 0. So what's the difference? If we're finding difference, we want to subtract. So let's subtract 29,029 minus 1,414. So let's use our subtraction rule. Keep the 29,029, change subtraction to addition, take the opposite of that second term. So it becomes plus, so we want to add these two numbers up. And our difference, or when we add them up, we're going to get 30,443 feet. Right? So our total difference here is that 30,443 feet. Okay? So those are just a couple examples representing some application problems using integers and then using some of the rules that we know to solve problems with integers to solve these problems. If you like this video, leave a like, comment, and subscribe. First Coast Math Clinic.